Hello everyone, my name is Michael Neal, and I will be hosting a series of video blogs on rapid prototyping and additive manufacturing technologies. Now if you're not familiar with what these terms mean, don't worry because you're about to see them in action here in just a moment, but for now, just think of them as the opposite of a mill, which is a subtractive technology. So with a mill, or subtractive technology, you start out with a block of material, and the mill then cuts away at that block until you're left with your part. Now with additive technologies, you start out with only your material. The material is then added one layer at a time as your part is grown. This is also called growing a part. So the topic of today is going to be the multi-material PolyJet. I'm very excited to get this underway. This technology is literally revolutionizing the product development phase for thousands of companies. So without further ado, let's head over to Grow It, which I'll be referencing throughout the videos as well, and take a look at these machines. I'll see you soon. Now as I was in this room recording, there were 3 different machines running simultaneously paired with a large air conditioning unit, and so I really decided it would be best to just remove the audio altogether. So, taking a look at the machine here, you're going to see that platform there in the middle. That platform will drop 1/2 of 1,000th of an inch as that print head finishes each swipe. The print head itself is printing at a resolution of 600 dpi, so thousands of tiny little nozzles depositing that resin, which is then cured by those 2 UV lights on the left and right. Now if we open up the machine and look under the hood, so to say, you can see that it actually holds 4 different material cartridges here. The material cartridges on the left are for support material, which I'll talk about in a moment, and then on the right we have the build material. Now the ability to mix and match materials on the fly is quite impressive, and you're going to see that fairly soon with our sample parts. But first let's look at understanding the support material. With each part, unless you're just building a cube, you have to have some kind of material to fill in all the crevices, all the overhangs, and so forth that make up your part. That material is support material, which just flakes away, as you can see here. We actually rinse it away, we don't actually flake it away with our fingernails there. But we're going to remove that, and now you can see, after that support has been removed, all the hinges, even though this is built all as one part, will function, and you can move this apart around all over the place as if it were built and then later assembled. So, very impressive because you're not limited to any of the limitations that you would see with a CNC process or any kind of subtractive process. Looking at the sample parts here, this right here kind of goes to show the natural finish off the machine. You can see those build lines there, but look at that nickel. I mean, those are very small lines. When you run your finger across, you really can't even feel those lines. Take a look at this key fob here. 2 materials built simultaneously. You have a soft and a rigid material. You can see through that rigid material. Goes to show the transparency of some of your material options. And here once again kind of goes to show how impressive the resolution is, but then also the ability to build these functioning parts. Look at this chain here. As you can see, it's modeled all as one part. It's not later assembled. So we're just going to scooch that to the top left corner, hit go. Once that support material is removed, you have a functioning part, even though it was built all as one. This right here was built by one of our student employees. He designed it for his final. He's got his camera there inside the case. The case itself has that rubber overmolding, and then also he incorporated little rubber dots throughout the part to give it that cool texture, even though you really couldn't manufacture that in real life. Because again, just keep in mind, the rubber and the plastic is not molded together, even though we might say overmolding. It's not attached at some later date. The machine is literally using different materials on the fly, mixing them as it builds your parts, and simultaneously adding those features to your part. So here, for example, you see 2 different materials, translucent material, and then within that skeleton. This shot right here just goes to show the finishing that you can do. Exact same part on the left and the right, but the right part has been sanded and then plated, and just look at the reflection of the nickel there to kind of show you what we're talking about. Here, same student employee scanned his phone, played around with it in SolidWorks, and then built it on the machine. This shows just kind of some very small high resolution gears. This is just the housing for a GPS device. As you can see, it has the rubber component as well. And finally, our last sample part is this ball and socket type piece right here. Alright, so let's quickly talk about the materials that go into a multi-material PolyJet machine. On the rigid side, for the most part, the materials are all very similar. They simulate an ABS plastic. It's not going to be as strong because it is a resin-based material that is a simulant, so it's not the pure ABS plastic. You can get a pure ABS plastic using other technologies that I'll talk about in future videos. But when you're dealing with a PolyJet, your materials will be this weaker, comparably, material that comes from that resin that we saw in the video. So, keep that in mind. Basically, for the most part, and you can check out the specification sheets for the specific details, but most of the rigid materials are very similar with the exception of the color, which I will now go into. You can have white, black, gray, blue, and there's the transparent material as well that kind of had that amberish tint, if you remember. So, those are your rigid options. Over on the soft side, if we're dealing with scale A, you can get anywhere between 27 and 95 scale A. You can't hit every single hurdle, give or take 5 or 10 here or there, but you have a lot of different options there. So you can have really, really soft, flexible parts. You can have kind of more rigid, barely flexible parts. That would be in the 95 range, obviously. They're on the soft side. And then, of course, at Grow It, because they have the multiple material machines, you can literally mix and match as you go. You can have more than one material on the same part. It will build it all simultaneously. There is one more rigid material that I failed to mention, actually, and that is called Durus White, which simulates a polypropylene. So that'll be completely rigid, but it will also flex a little bit more than the ABS simulants will. And that is a wonderful feature to have on a PolyJet machine because a lot of people are building these very small clips, or they're building things that need to snap, or they're building living hinges, and that's where that Durus White material comes into play, which a lot of service bureaus don't even offer. Don't know why, because it's a wonderful material. So, that concludes the materials, and that's going to conclude the PolyJet discussion. There are other items that I couldn't get into just for the sake of time. I don't want this video to drag on, but that does conclude the educational portion of this video. So feel free to stop if that's your primary concern in this video. However, I am going to spend another minute or two because this is my first video talking about my sponsors, Grow It, the amazing people over at Grow It. So Grow It is a service bureau, which means that they do not own, or sorry, they do own machines, but they do not build machines, they do not sell machines. Instead, they operate the machines, and they are a service bureau for you who might need to order parts, but you do not want to purchase your own machine, which, quite honestly, and I'm not just saying this, that is the way to go for the majority of people out there, because when you consider, it's not just the purchase price of the machine, there's the material that goes into the machine, which will expire on you if you don't use it. So if you want to offer all these different materials to, your company, and you don't use every single one of those materials before they expire, you're looking at thousands of dollars in lost material, and you basically wasted all that time stocking all of that. On top of that, there's the operator of the machine. You have to dedicate someone to learn and perform all the functions, the calibrating of the machine and the cleaning of the machine and all of that. Lots of costs there that you're not really thinking about. There's the depreciation of the machine. And then furthermore, there's just the fact that there's so many different types of machines. Today we only talked about the multi-material PolyJet. I have yet to tell you about SLA, FDM, SLS, DMLS, all these other technologies. And so really, and each one of course is good for different applications. And so unless you're really just using the exact same technology for the exact same kind of application over and over and over each week, unless you're doing that, you should really consider, having a service bureau, because they're running the machines more efficiently. And I mean, Grow It, for example, they were the first service bureau in America to offer the multi-material PolyJet. They now own more of those machines than any other company in the world. They're running them extremely efficiently. Their technicians are all trained to calibrate and keep up with all the maintenance and just all those things that you really don't consider. So, Can't say enough good things about Grow It. Thanks again, you guys, and I will see you guys next time.